Welcome to week 9 of programming with C++. Now, in today's video, we'll be discussing about classes, or we'll be learning about classes. So let's just get right into it. So first of all, what are classes? Now, classes are hold on a second. Have classes. Yeah, sorry about that. I was caught. So um first of all, we need to know what classes are. So a class in C++, right, is a user-defined data type that serves as a blueprint for creating objects, right? Basically it serves as a blueprint for creating objects, right? And it's a user-defined data type, so it is created by the user. Okay, it's created by the user. It's not something that's inbuilt. The user creates it, right? So a class, key things you need to know about a class. It is user-defined and it serves as a blueprint, right, for creating objects. Okay, it's the foundation of object-oriented programming, right? We've come to, consider object-oriented programming, right? That is a programming language that implements object-oriented design. So any programming language that implements object-oriented design is referred to as an object-oriented programming language. Okay, so um, the key components of a class. Let's move on to the key components of a class, right? So the key components of a class are basically the attributes, the methods, and then the access specifiers, right? Now, for the attributes, okay, they are like the properties, or another name for the attributes are the properties, right? So they are the variables that store data. The variables that store data, that's the attributes. And the methods are also known as functions, right? And they are operations that are used to manipulate the data. Methods are basically operations that are used to manipulate the data, right? And then access specifiers control the visibility of the members of the class, right? So for the access specifiers, we have I think three types here. We have three types: the public, the private, and then the protected. Public, private, protected. So let's move on to class definition so that we now understand how the components or the key components of classes are implemented here. So we have the structure. Okay, now for the structure of a class, okay, or the structure of a class definition or a defined class, right, is the class followed by the class name. Okay, so for example, class, my record, class, Stefano, class, Kofi, class, Ama, class, GCTU. Yes, so class and then the name of the class and then the name of the class and the name of the class. Okay, so class name, then your curly braces. Now within the curly braces will be your access specifier. We've gotten to know what they are. So they control the visibility of the members. So public, private, or protected, any of them will do for the access specifier. Then you bring your column. And then after you bring your column, you come down your attributes. Okay, your attributes again, once again, attributes they store data. Okay, attributes store data. They are variables that store data. Okay, so over here, you can, you know, declare your variables or define them over here. That's what you basically do at attributes. And then for the method, they are operations that manipulate data. Okay, so most of the times they are functions, right? Most of the times they are functions. The methods are functions. So maybe for example, you can have um maybe int get number, right? We've done functions, so we know the how functions are or how the basic structure of functions are. So maybe your int, then um add number or something, add number, then your brackets, then your parameters will be in the bracket, then your curly braces. In the curly braces, you have your arguments and all that. You have uh your statements that will perf- perform operations on the data you've provided in the parameter or from the parameter, and then you return statement or value. You return statement or value. So that's the basic structure of a class, right? So you have your class name, and then you introduce your curly braces. Within the curly braces, mind you, all the things that are within the curly braces of the class are the class members. Okay, so anything that you bring uh, within the curly braces of the class you created are members of that class. So your class name, your curly braces, your access specifier will be inside the curly braces, your attribute will be inside the curly braces, your method will be inside the curly braces. Access specifier, there are three types: public, private, protected. The attributes could be you declaring or defining any variable or change because they basically store data. The attributes are variables that store data. So over there, that's what you do there. Then your method is basically your function, right? Or any operations that manipulate the data. So basically functions, right? So that's the structure of the class. So let's create a class. So let's open our code blocks. Okay, let's create a class. Mind you, classes are also created within the global scope. So let's so then syntax was your class, right? Class and your class name. In this case, let's go with my record. Right. It could be anything, but I'm choosing to go with my record. My record. So curly braces, then within these curly braces you introduce your public or sorry, your access specifier. In this case public. And your colon. Then you come down, then your attributes, right? Mind you, over here your attributes can be as I said. Maybe you can choose to initialize or declare or yeah, any data type over here and all that. So over here I'll choose to just declare, right? So let's declare int. Hey, sorry, let's declare a variable. Let's just declare this, right? Let's declare this. Okay, my age. String name, right? So these are attributes. Okay, let me comment it for clarity. Okay, attributes. Then this one also is also an attribute, right? So that you can see what I was talking about. So yeah, these are attributes. Okay, then methods. Let's count down to methods. So int get age, right? So a function is basically a method, right? A function is basically a method. So this is a method, and then let's see what else. Let me terminate this. Okay. Uh, Also, uh, okay, void get age. Yeah, can also use that void get age. Sorry, it's a function. So our brackets. Oh, our bracket needs to come here. So this is also a method. Now this is basically the structure of a class. Then you end with your ending curly braces, of course. You end with it, right? So I've created a class called my record, right? And it's a public. The access specifier for this class is public, so it means that it can be accessed, outside of the class, and um, my attributes are within the class, or my members include um, my age, name, get age, where the my age and name are the attributes, okay, and then the methods are the get age and then get age again. Really, that just repeat this twice. Let's just use this. Let's just do this. Get name. Yeah, get name. Get name. Oh, this sneak over there. Get name. Okay, so that is basically the part, the basic structure of a class. The basic structure of a class. So we've created a class called my record. So let's move on to access specifies. Access specifies, right? Now, mind you have I think they define the class. Did we define the class? Yeah, we define the class. We define the class, right? We define the class. Okay, so let's move on to access specifiers. Okay, now for access specifiers, they determine how class members can be accessed. Okay, so I have mentioned. I think I mentioned them: the public, the private, the protected. But do we know what they are? Let's see what they are, or let's see what it means. when we say the access specifier is public, what do we mean? It means that the members are accessible from anywhere, right? So it can be outside of the class, inside of the class, or within the class. Okay. So uh, let's see. Okay. Let me see if I can. Okay. You there's no need to demonstrate this because um it's basically writing private, public, or protected over here, right? But then what they will do varies. That is what we are looking at. So let's concentrate on that. So for the public, they can be accessed directly from outside, right? Or the members are accessible from anywhere. Okay, and then for the private, members can only be accessed within the class. Okay, for the private, members can only be accessed within the class. So let's look at the protected as well. For the protected, it's very similar to the private, but it's accessible in derived classes. Okay, it's accessible in derived classes. So that is all for the access specifiers. Okay. For the class definition, I mean, we've gotten to see what it is, right? And the components of a class, I spoke about it during the beginning of the video. So in case you've forgotten, you can go back to the beginning. It's over there. Now for the class methods, right? There are functions that belong to the class. There are functions that belong to the class. Okay. So for the class methods, I told you that they are basically functions. I've even demonstrated it. If you've forgotten, let me refer you to what the class method looks like. Okay, this is what the class method looks like. They are basically functions. Okay, now there are two ways to define functions that belong to a class: inside class definition, outside class definition. Okay, so let's see the inside class definition. So this is basically the structure of an inside class definition, right? The class was defined inside the class, or the method of the class was defined inside, right? And then for the outside class definition, the method of the class was defined outside. Okay, it was defined outside of the class. So let me quickly demonstrate that. Okay, so let's see. So this is my class called my record, right? Now it's an the public sorry, the access specifier here is public, right? Now uh this is my attributes for the class. These are my attributes for the class. Let me just stick with one attribute. Let me comment the one over here. Okay. Then this is my method. Int get age, right? Int get age. So let me also remove this one or comment this one. So this is my class. It's public. This is my attributes. This is my method. Now I can access this method within the class, right? It's possible. That's the inside class method, right? So I can just see out um gets sorry gets age. So by doing this, I've uh access the class, or I've performed an inside class method definition, right? As we can see over here. Okay, over here, this is the inside class method, right? And of course, our class, my record, our access specifier, which is public. This is the method over here, right? The void gets each. Okay, then we've accessed it within the class. We've accessed it within the class. So see out this pointer my age. Okay, we get to this pointer, don't worry. And then let's look at the outside class as well. Uh, ah, is um, can't let me correct this. There's a uh-huh. I never brought any semicolon in the brackets. Okay. Okay. Yeah. Okay. Okay. So this is the inside class method, right? The inside class method. And then let's look at the outside class method. This will basically not be inside the class to come outside. So let's just move this, then come in. Then let's bring it out. Okay. Uh, so in order to access the class from outside or using the outside method, you basically have to follow the same principle as accessing namespaces, right? When you create a namespace and then you want to access it directly, what how you access it, that's the same way you access a class. Okay, so I want direct access to get age, right? So I bring the data type, that is the void, sorry, the int. Yeah, we use the int here. Sorry, the int. Then my record, right? My record. I hope you remember this. This was we did something similar like this in namespaces, right? Where if you want direct access to a member of the namespace you created, the syntax or the structure is basically the name of the namespace. But in this case, we are doing classes, so the name of the class you created, that is my record. Then the scope resolution operator or the double colon, right? And then um the particular member you're accessing. Okay, so int my record, then the double colon. Then in this case, we are accessing get age, or we want to access get age. So then, yeah. So let me, sorry, uh, so int my record get age. Then let's see, yeah. So this is basically it, right? Oh, sorry, sorry. I forgot to bring the get age is a function. So you also have to bring the brackets, right? It's like the bracket is like basically, I don't know, attached to the thing, right? Because without the brackets, you wouldn't have your parameters, so you need to bring it. And also our curly braces, right? The statement will be within the curly brace. I also forgot to bring the curly brace. You need to always be checking for these things because if you don't bring them, that means error in your code. So I think the code is correct now. Yeah, code is correct now. So I'm just showing you, the structure. Okay, I'm showing you the structure of the class and all that. And I've shown you how to access the class using inside method. Also how to access the class using the outside method, right? So let's move on. So let's move on to parameters. Yes, class methods, parameters. Now it basically it follows the same principle as functions, parameters in functions. It's the same thing. Okay, so over here we are just going to be doing functions. Okay, for the class method, we are just going to be doing functions, right? Now the problem will be, accessing the parameter. Hey, sorry, uh, accessing or passing arguments. Yes, passing arguments uh from the class method. Okay, so let's first create a parameter. So using the same my record. Okay, no, no. In fact, let's change this. I would want to actually run the code so you see how it works. Okay, so let's name this class calculator. Yeah, calculator. Let's name this calculator because we would want to be finding the sum of two numbers. Okay, so calculator, right? So this class is called calculator. Now it is public. Okay, and let's go on ahead to int num, right? So that's our attribute, our first attribute, int num. Now int sum. No, no, get some. Sorry, get some, get some. Then int. We are just applying the knowledge from functions. Okay, so if you watch the previous videos, I did functions, so you can go back and check that one. I think functions was week five or week six. Sorry, week five or week seven. One of them. I'm pretty sure it's week five. So our first num one. Let's go with num one. Okay, you know what? If I would uh That means I have to, okay, let's use letters instead. Let's use letters. So I'll declare A as an integer and B as well as an integer. Okay, then can just go on ahead. A, oh, you don't have to do this twice. Okay. Let's forget about the attributes first. Okay, so let's forget about the attributes. Let's just go straight ahead, right, to the method. Let's just go straight because everything will literally be defined in the method. So int get some int a, comma int b. Okay, then go on ahead to, should I delete these comments? Okay, let me remove these comments because we don't really need them anymore. So let's just remove them. Oh, okay. So just now, since we are finding the sum of two numbers, right? So int results then are equal to are equal to a plus b, a plus b, yeah, plus b. So return results. Okay, so we have created a class called calculator because we are finding the sum of two numbers. We find the sum of two numbers, right? A and b. Okay, so it's a public class, or the access specifier is public, and over here our class method is the get sum, or function over here is the get sum function, where we are finding the sum of A and B, the sum of A and B. So we would like to pass an argument now. Okay, we'd like to pass an argument now. Mind you, we are dealing with class method. Okay, class method by basic parameter usage in class method. Okay, basic parameter usage in class method. So that's what I've demonstrated. Okay, so we have introduced parameters. Okay, just like functions, we've introduced parameters in our method over here, right? Now we want to pass arguments to this class method. We want to pass an argument to this class method. Okay, so what do we do? What do we do? What do we do? What do we do? What to do? Okay, so we come. Let me just clear this. We don't need it anymore. Okay, so in order to access a class, sorry, in order to pass arguments, in order to pass arguments to the class, we need to come down to our main function. Okay, we need to come down to our main function. Then we need to create an object of the class we've created. We need to create an object of the class we've created. What do I mean by that? This is how we create an object of the class. So we don't have to access the class, we need to create an object of the class, then pass the arguments, right? So within our local scope, uh, we create um, the object of the class calculator, right? So is it a capital C? Okay, a small c, calculator. Sorry, calculator. Oh, calculator. Cal, calculator, calc. So this is how you create an object of the class calculator calc. So the syntax is basically the name of your class and then an identifier, right? The name of your class and an identifier. So in this case, I use calc. You can use anything you want, right? Then let's come down. So int results, right? Int results. Um, let's go with uh, let's go with. Okay, no. Let me just go on ahead to do this. Okay, get some, get some, then get some five, comma. Hey, is it five I typed? Yeah, five, 3. and see out, see out, get some. We want to display our answer, so that's what we are doing. Get some. Um, am I doing it right? Assignment. Okay, even if there are errors, I'll correct them. So let's see if okay, there's an error here. Let me see why there's an error. See why there's an error. Let me see why there's an error. Okay, so um, let's see. Uh, so we're here, right? I was called, so I had to pause the video. I think we had an error. So yeah, still on this error. Yeah, since we created an object of the class calculator, now we use that object, right? So uh, calc. Oh, what is this? Calc dot get some. Yeah, this is the basic structure of how to pass arguments, right? You first create an object of the class called calculator. In this case, I called it calc, right? And then in order to perform your operations, there is the object, then you bring the dot, then you bring or you pass the member of the class with the arguments within the parentheses, right? So your calculator or your class name, your object name, you terminate it. Then your object name dot the member, your object name dot the member of the class that you've created. That is, in this case, get some, right? Then you pass the arguments, okay? Then you pass the arguments. That is 5 and 3. Then you terminate. Now we want to display uh, the argument over here, right? Or we want to display the result, okay? So over here, let's correct what I've done. Bring our calc again, then our dots, then 5, 3. Yeah, this should fix the code. Okay, so this is the basic structure of how to pass arguments, right, to a class method. Okay, so your class name, then your object name, terminate your object name dot the member of the class, that you are or that you want to use. Okay, in this case, get some. Then you pass your arguments. Then you terminate it. Should you want to display your results, it's the same thing you do here. Just that in this case, you instruct the system that you want to display it in the console. So you bring your C out again. Then let's see. So eight is our answer. So our answer should be 8. So this is basically how uh basic parameters and passing arguments in a class work. Basic parameters and passing arguments in a class. This is how they work. Okay, so let's move on to class constructors. So a class constructor is a special method that is automatically called when an object of a class is created. Okay, a constructor is a special method that's automatically called when an object of a class is created. So to create a constructor, you use the same name as the class followed by parentheses. So basically, the structure of a class constructor is like creating a normal class, okay. But there are some rules. So let's look at the rules. So rule number one, it also has the same name as the class. Rule number two, it has no return type, not even void. Rule number three, it is usually declared public. Rule number four, it's automatically called when an object is created. It's automatically called when an object is created. So let's look at the structure. Okay, so over here, class my record. Okay, then it's usually public. So you follow the rules. Okay, so it's usually public. So as you can see, it's public over here. It follows the same name as the class. So the class we created was my record. So over here, the class constructor is also called my record, right? And then let's look at okay, it has no return type. It has no return type. It has no return type. So nothing like int, void, no, nothing like that is attached to the the oh the function. Okay, you see, when you're creating the function, when you're creating the sorry method. Okay, method and function is the same thing. So yeah, when you're creating a method, okay, you see there's a return type. Okay, like the ones you created here. Let's you see the one I created here. There was an int return type or data type. Okay, now in constructors, there's no return type. There's no return type. So you just go ahead with the identifier. Okay, you just go on ahead with the identifier. That's it. Or the method name or the function name. You just go on ahead with it, right? So there is a constructor. So let's create one and see. So basically, what you are, let me comment all this. Okay, let me not comment this. Let me not comment the ones down here. Let me just end it here. Okay. So usually what you are saying is that create a class constructor. Okay, to create a, I'm just showing you the structure. Okay, so as have the same name as the class that you've created. Okay, so that is in this case my record, right? My record, and then within your curly braces, right? You have your access specifier, which is usually public for a class constructor. Your access specifier is usually public. Then your method is, or the constructor, another name for that part is the constructor. Okay, the constructor is where I type my method. It's just the name, or yeah, the name of the class. Okay, the name of the class now. So my record, and then your brackets. Okay, so it's just like how you are somehow creating a function, but in this case, there's no return type. So just my record, and then your brackets, and then your curly braces, then your curly braces. Okay, so within the curly braces, you would have your statements, right? So maybe see out my record. It should be in double quotes, my record. Then yeah, terminate it. So this you've created, oh yeah, you've created a class constructor. Yeah, with this you've created a class constructor. So class my record public. So is the same name as the class that you created. It's usually public. It has no return type, and then yeah, how many rules did we even consider? I think four. One, two, three, four. Yeah, it's automatically it's, it is automatically called when an object is created. Yeah, so it is automatically called when an object is created. So yeah, I think that's it for the class constructors. Yeah, that's it for the class constructors. Okay, so let's move on to class destructors. Class destructors. So the destructor is a special method that is automatically called when an object of the class is destroyed. It's automatically called when an object of the class is destroyed. So let's, yeah, mind you, let me make this clear. I don't know if I've already made it clear. The constructors and destructors, they are all special methods, right? They are all special methods. So they are methods, but they are special. What makes them special are because of the set of rules that are attached to them, right? So they are basically methods. The class constructor is a method. The class destructor is a method. So let's go on ahead to look at that. Before we go before we go on ahead to look at that, it is also prefixed. Okay, a class destructor is prefixed with a tiled. A tiled. This symbol, let me highlight it. A tiled. This is a tiled. Okay. Yeah, and then it also has no return types. It has no return types or parameters. It has no return types or parameters. And it's used for cleanup, okay, like releasing memory. Yeah. So let's look at this example as well. So we are creating a class destructor, okay, a class destructor. So let's create that. So over here, let's maintain this class by record public. Now it also has no it has no return type, but then it is prefixed by tiled. So let's add tiled to the my record. Tiled, or tiled. I don't know how it's pronounced, but anyhow, tiled, anyhow. Right. So this is a tiled or tiled. So yeah, that is the distractor. Okay, this is a distractor. So I've created by doing this, I have created a distractor. As easy as that. Okay, as easy as that. So let's move on to the next thing. We have spoken about access specifier, so I'll just skip this. Okay, so let's move on to the this pointer. Okay, so it's a pointer that points to the current object's instance. A pointer that points to the current object instance. So it's used to access object members within methods, and it helps distinguish between class members and local variables with some names. So it used to access object members within methods, and it helps distinguish between class members and local variables with the same names. So that's the this pointer. Okay, so let's go on ahead to look at an example of a this pointer. Okay, let's look at an example of a this pointer. So this is the example stated here: class my record, public, int my age. These are attributes. This is the method, right? Now within the method we have our this pointer. This pointer, and what did we say that this pointer is? We said that it's used to access object members within methods. Used to access object members within methods, and also uh yeah, it also points to the current object instance. Yeah, and also it helps distinguish class members and local variables with the same name. So let's create a this pointer. Let's create a this pointer. Okay, so can we here we can create one here. Let me just edit the code. Okay, int my age, then yeah, let's use void get age. Yeah, then oh, int my age. Then so within here we would have a see out message. So instead of using sorry, let me edit this. Okay. Okay, I don't want to display it, so then let's just do it this way. Okay, so this pointer, this pointer, this pointer, my age, my age. Yeah, this pointer, my age. Then assignment to print. Okay, assignment to print out my age. Okay, yeah. So this pointer, my age, right? This let me highlight this. This pointer, my age refers to the class member. Okay, the this pointer my age refers to the class member. This pointer my age refers to the class member. So the class member in this case is my age, right? The class member in this context is my age. So the this pointer my age refers to the class member. Okay. So that's how like this pointer is like. So that's how this pointer works. Okay. So it will point to the current object instance and can also be used to access object members within methods. So that is that for the this pointer. So let's move on to objects. Now what is an object? An object is an instance of a class. An object is an instance of a class. Now it is created from a class. We've already seen an example of how objects are, right? So um to create an object of a class, you you specify the class name followed by the object name. Okay. So I think I demonstrated that the class name followed by the object name. I think I've demonstrated that already. Okay, so I'll now show that again because I have done that in the code. Then multiple objects. We can, create multiple objects from a class, right? So the syntax is still the same thing. Your class name, your object name, your class name, your object name. Okay. Then accessing class members. Now to access your class members, I think I've also demonstrated that you need to create an object for that class. To access the class members, you need to create an object of that class. So your class name, your object name. Then you use the object name, eh? Use the object name in combination with the dot operator to access the members of that class. Okay. I have done that in the previous code, so I don't want to demonstrate that again. Okay, but let me highlight this for you here. Okay, so I created, let me on comments this if that's even a word. So in this example over here, I created a class called calculator with a member called getSum. Now I wanted to access the class, right? So the member getSum of the class calculator. So I introduce the name of the class, which is the calculator, or which is calculator, sorry, and then the object's name, which is calc, right? Then the object's name in combination with the dot operator, right? Then I call out the class member. Okay, so that's what I did here. So the object's name, the dot operator, then the um, class member. Then I passed my argument. This was passing arguments, right? But the syntax for accessing class members, you don't really have to add this, right? Unless you know what you are doing. Maybe you are passing an argument. So that is the syntax, right? So that is it for accessing class members. And then modifying class members as well. You can modify your class members, right? You can modify their attributes, right? So we just introduce the assignment operator. That's all. Just introduce the assignment operator. So let's go on ahead. Then we have static members, right? So static members are not associated with objects of the class, but the class itself. And they can be accessed directly through the class without creating objects. Both attributes and methods can be static members. Okay. So basically attributes and methods are static members, right? And static members they can be accessed directly without creating objects. Yes. So in this example, uh, static string my date of birth, right? So this string my date of birth is a static member, right? It's an attribute, and attributes are static, or attributes are static members here. So this string my date of birth can be accessed directly without creating an object, right? So as you can see, string my record, then the uh, double colon, then my date of birth, then he modified the attributes by introducing the assignment operator. Okay, so that is static members, right? Now, if you want to access the static member, Then you just come to the local scope, right? This is all done in the global scope. You do all this in the global scope. Okay, do all this in the global scope. Then you just come down here and then you access it in the um local scope. Okay, you just see out my record, my date of birth. Okay, so your class name and then your static member name. Okay, your class name and then your static member name. Then your class name, sorry, yeah, your class name, yeah, your class name, double colon, and then your static member name. Then that's it. Okay, so let's quickly demonstrate that. Okay, so okay, let's just this is my record. Okay, so let's just comment this. So class my record, public int my age. Uh, this is a static member, so static static int my age. Then what else? You then go ahead to in that. Okay, then you come down. Let's remove this. We don't need this again. So you just initialize the static member. So in this case, ends my record, my record, my record. Then double colon. Then my age. That is the name of the static member. So the class name and then double colon the name of the static member, which is in this case my age, right? My age. Then we can we are initializing the static member my age, so we just assign a value to it. So hey, sorry, 25. Then we terminate it, right? So if you want to access this, we simply just come to the int main within the int main function. Then we don't need this again, so let's just come there and then see out then your class name my record, then your double colon, then your static member name my age, my age, then red line. Okay, so this is basically the syntax for class sorry, static members of a class, members of a class. So this is to create a static member, or this is to initialize a static member, and then this is to access a static member, right? So we access static members in the main function. Now let's move on to the next thing. So classes in OOP, that's object oriented programming. Now these are things we did from the beginning. Okay, these are things we did from the beginning. So I wouldn't waste much time here, right? So I'll just explain what these three are. These three concepts are, and then we just call it a day. So encapsulation is like controlled access to components of objects, right? Controlled access to components of objects. Whereas in inheritance is the creation of a new class or the creation of a derived class that inherits the behaviors and properties of an existing class. Okay, and then polymorphism is yeah, polymorphism means many forms. Okay, many forms. And it occurs when we have many classes that are related to each other by inheritance. Okay, so it uses methods inherited from another class to perform different tasks. I wouldn't want to waste much time here because I explained all this into details in I think the first week. Yeah, the first week. So you can refer to that if you uh want to understand it. So that is it for week 9.